Hello, welcome to the second day of Global Azure Bootcamp Virtual 2020 edition. In this session, we are going to discuss how to modernize application code into a more manageable process involving ContainerOps, DevOps, and Database as Service in Azure. We are going to discover how we can use Azure Kubernetes Service and Docker containers to transform a traditional PaaS application into a containerized model, and also see how to manage that containerized application lifecycle with Azure DevOps, Azure Monitor, containers, and some other OSS tools. My name is Janaka Rangama, and I'm a Microsoft Azure MVP. I work as a Senior Principal Engineering Technologist at the Dell Technologies Microsoft Azure Stack Family Engineering Technologies team. We are going to discuss a real-life customer situation to understand more about these technologies. Our hypothetical customer, Fabric Medical Conferences, provide conference websites for medical community. It started as a small company with few small conferences a year, and now they have evolved into a well-known brand, and they handle over 100 conferences per year, and they're growing. Their customers has a limited budget, but it requires a significant customization and changing demands. Now, these changing demands drive various aspects of this system like UI and the backend, conference registration, and payment terms that requires to significant development times. Fabricum's customers, or the conference owners, are considered as tenant, and each of these tenants is treated as a unique deployment, and they have to modify a tenant's conference website to support their needs. A tenant's code is deployed to a specific group of load balanced Windows Server machines dedicated to maybe one or more tenants. And once the conference is live, there's a number of customer requests coming to Fabricum. If you look at the tech stack they're using, there are 12 developers who are handling development, testing, deployment, the ops management of all customer sites, so it's limited staff. And since the customers are asking more customizations in their websites, they have a number of issues with the efficiency and the reliability of their development and DevOps workflows. The technology they are using is the mean stack, that is Mongo, Express, Angular, and Node.js, and these conference sizes are currently hosted in Windows Server machines that are running on-prem. And especially the DB backend, the MongoDB cluster is deployed on Windows Server machines on-prem as well. There are a few key things this customer wants to achieve. They want to reduce the potential regressions that are in the functional tenant code when there's a change is made. They want to reduce the time to onboard new tenants. They want to improve the ability to roll back and recover post-change. Ideally, they want to see the individual areas where full regression test is not needed. That should not affect the site functionality. They need to reduce the overhead of managing changes and related deployments. And finally, they want to increase the visibility into systems operation and health. Now, taking all these objectives into consideration, you as a developer has to identify what their actual needs from a technical perspective. Now, if we advance to that needs that we need to identify, as the Azure developer and the Azure solution architect, you can have a discussion with this customer and find out what exactly the technologies they're looking to achieve this target. Now, in the beginning of the session, I mentioned that this session is going to be about converting a traditional PaaS application into a containerized model. So if this customer were to convert this application that is running on on-prem Windows Server machines into PaaS, it would require services like Azure App Service and a DB backend, so on and so forth. But this customer is looking to modernize this into a containerized model. So they need to choose a suitable Docker container strategy on Azure. And since they are currently using MongoDB, they're looking at changing it to Cosmos DB without any application changes. A popular choice of source control, Git repositories are the choice in this case, post-migration. And to automate the whole process, they're looking at Azure DevOps as the CI/CD tool of choice. They want to use deployment tools, CI/CD integration, container scheduling, orchestration, monitoring, and alerts to reduce the ops management footprint of the whole containerized solution. And they wish to complete an implementation of the proposed solution for a single tenant or a single customer and train the team to perfect the process. Let's look at what Azure Kubernetes Service offers in terms of deploying containerized applications. As you can see in the diagram, an AKS cluster is divided into components. There's a control plane which provides nodes that provide the core Kubernetes services and orchestration of application workloads. Then you have worker nodes that run your application workloads. In the control plane, when you create an AKS cluster, it is automatically configured. The control plane is provided as a managed Azure resource and it's abstracted from the user. And there's no cost for the control plane. You only pay for the nodes that are part of the AKS cluster, for the slave nodes. There are few things in the control plane that includes core Kubernetes components. Things like a kube API server, etc daemon, a kube scheduler, and a kube control manager. When you look at nodes and node pools, in order to run your applications and supporting services, you need a Kubernetes node. There can be one or more Kubernetes nodes in an AKS cluster, which is essentially an Azure virtual machine that runs Kubernetes node components and container runtime. The kubelet inside the node is the Kubernetes agent that processes the orchestration requests from the control plane and scheduling of running the requested containers. The virtual networking is handled by kube proxy on each node. The proxy routes network traffic and manages IP addressing for services and pods. The container runtime, on the other hand, is the component that allows containerized applications to run and interact with additional resources, such as the virtual network and storage. In AKS, Mob is used as the container runtime. It's time to see how AKS and Azure DevOps can be integrated together to solve this customer's challenge. As you can see in the diagram, when you push out code to an Azure repo, the next step after a build is completed is to push the same code into Azure Container Registry so that the functional code can be retrieved from there into the AKS cluster. Further along the development process, when you produce a release, what you do is, in this case, we are using Helm charts to deploy into the AKS cluster. You deploy the conference website, which uses the mean stack, into the AKS cluster that is running on Azure. Now I have a small demo prepared which explains some of the parts of this process, and it shows how you can leverage Azure DevOps in each stage of this journey. Let's take a look at that. What you see in the following section of the demonstration is that setting up the CI pipeline to push images into the Azure Container Registry. So I'm logging into the build agent that I have running on Azure, and I'm moving to the repository folder where I have the the web layer of the application. And I'm going to add a Azure pipelines.yaml file, which contains the required code to push this into the ACR. So I have added the code that is required there, and I'm going to save it now. And then finally, I'm going to commit the changes I've made with git commands. Moving on, you can see that the Azure DevOps tooling has automatically detected a pipeline which you have just pushed into GitHub. So this is from the YAML file that we created earlier. So this actually contains information about how to push the code to ACR, and we are gonna check the pipeline and run it once to see the status of that pipeline. So I actually initiated a run on that pipeline, which does build and push the Docker image into ACR. Now, as you can see in Azure DevOps, the status changes a number of times, and it can take some time to complete the actual pipeline itself. So you can see that each stage in this pipeline, like building and pushing the image to the container registry, and what are the post job checkout for this particular job. It's gonna take some time for this to complete. Once it's completed, let's come back and see what's the status, what we have missed, are there any errors, things like that. So the pipeline is still running, and now you can see it's completed. You can check what are each task completed and what if there were any errors in the pipeline, whether we should investigate it. So you can see the actual logs of the pipeline. Now we have done this for the one piece of the code, which is the content web. Now we're going to do the same for content API. We already have a YAML file in that particular repository. We have uploaded that previously when we created the demo. And what I'm going to do is I'm just going to run that pipeline so that it completes the build. So I'm setting up the CI with Azure pipelines for the content API repository as well. Now we are going to execute the pipeline run cycle. Okay, it's executing. I can see it's building and pushing the Docker image for that particular repository content API as well. If the Azure DevOps environment you have is busy, it will queue the execution. As you can see, it's completed. There wasn't much of a queue there. And now we are moving to the content init repository, and it also has a predefined YAML pipeline that I've created. I'm going to make some changes there, and I'm going to execute that pipeline as well. All right, so I'm going to put the commands and create the pipeline, and it's going to be executed now. So it's building and pushing the Docker image for that particular repository as well. So if I go to the Azure Container Registry, I can see there are a number of tags there. So the one I'm interested in is 0.1.1, which is pushed by the Azure DevOps pipeline. So I have something like that for all three of the repositories. You can see that, and these are the manifests of those repositories. Now, as you can see, we are gonna further edit the Azure pipelines.yaml for the content web repository. So the first stage, we create a job called build and push, which builds and pushes an image to the container registry. And I'm gonna add another job which essentially build and pushes an Helm chart, and I'm going to incorporate that into the same YAML file. So I've added the code that I required. I'm going to save it. Now it's going to trigger a brand new build job, and yeah, the build has started, and you can see the progress by going through the build. So there are two jobs in that stage, which is build and push the Docker image, and the new job we added, build and push the Helm chart for this particular repository, which will deploy the code. Okay, now you can see the progress of this job, and it will take some time to complete. Remember, these jobs are serial. They're not running in parallel. We've defined them as serial jobs here. So once the first one is completed, the push part, the Helm chart part will start. Okay, it should finish fairly quickly. I can see that it's good progress, and when it's completed, let's review the status. Okay, looks like it's completed now. I don't see any errors here. Okay, let's see whether the build is successful. Yes, it is. It has completed. Now the next part is the deployment to AKS. So one of our targets was to deploy the AKS deployment to AKS to automate that piece of the equation. Now I'm going to add something called a new stage. So I already had one stage which just does the Docker part to the ACR. Now I'm going to add another stage, which is the automation of AKS deployment. So I can do that same thing that I've done. I'm just going to add another stage which does the deployment to AKS. So this is also a YAML definition. The errors you see there is basically indentation errors. So if you are doing this in production environment, make sure that you push the code, not just copy paste, and make sure before you push in the code that your indentation is correct. So for the sake of the demo, I'm just doing this on the fly. Now it looks good, so I'll make sure the indentation is correct. Okay, the stage is now defined, and I should save this stage and the new YAML file. I'm going to put a comment there saying add AKS deployment as the stage command, and I'm gonna start the build. So yes, that's done. Okay, see, so the build should kick in now. I haven't had any changes since the last build, so it should be fairly quick this time because build and push stage didn't have any changes. Yes, it was quick. You can see it does all the things that we would have done manually, like Helm upgrade and Helm install and the Helm repo upgrades, things like that, using the YAML that we provided in the pipeline. So right now in the background, it's pushing the code. Oh, it has actually completed to the AKS cluster. So you can see the deployment to AKS is completed, the build stage, build and push is completed, the jobs are successful, and yeah, so our deployment part with Azure DevOps is completed. Now I'm gonna go to the actual website and see everything. It looks good. Yes, the functionality is intended. Okay, yeah, I can see the information is there and the stats are there. All good. Let's go to the AKS clusters Kubernetes dashboard. Yes, so I can see there are two deployments. So we've just done the web deployment, and we go to the pods, we can see the number of pods. And if I go to service, you can see that web service that we've just pushed. And I'm going to browse from here. Yes, so the website is live now. Now, what about monitoring of this application? I'm going to see the Kubernetes cluster that is running on Azure, and I'm going to see what's inside. So if I go to inside section of monitoring, I can see all the monitoring matrices of that particular Kubernetes cluster there. So I can see the CPU utilizations, the health of nodes, the health of controllers. And furthermore, I can dig into logs and see if there are any significant errors. So as you can see, I'm going through the health now. I'm gonna explore what the container situation looked like. Right. So it's monitored the whole cluster. Okay. And I should be heading to containers. Oh, these are the number of containers that are running inside this environment. I can see a few warnings there, so you can get a good idea about what's running inside your AKS cluster. And if I click one of those warnings, I can see what's wrong there. So it looks like it's a status unknown, but I'm not too sure. Maybe I'll just have to go to the, okay, take this again, and let's see about the deployments tab here. Oh, this shows the deployments that I've completed in the Kubernetes cluster. And yeah, let's go to the controls back again. You can see the controls. I'm going to just check for web. Yeah, I can see the stats for that. If I go and check the same thing in containers as well, the web container. There's one that has been running for some time, so I'm gonna see the CPU usage, and I'm gonna explore the pod and see whether there were any significant data to be examined. Yeah, so now what I'm gonna do is I'm going to explore that particular pod further. I'm going to see whether there's any live data in this pod. Oh, there's a bunch of live data. So this is a cool feature in Azure Multiple Containers where you can see the live data coming from a container. And I'm going to then see what are the Kubernetes events logs. So this will take you to Azure Log Analytics, automatically generate the KQL query. There's no results found there. I think I should go back and check the other instance of the web container that was running. So basically, let's hit that. Containers. I'm going to search for web. Yeah, the old one that was running, the older pod. Yes, it should have more data there. So we've container logs. Okay, the query is generated. Oh, it shows the log from there. Good. Now here I'm gonna see the whole process that I've done. So the initial commit, I haven't really showed this part, though this was pretty much done through the build agent. So the commits were manual through the build agent, and you see that the upper portion was done through Azure DevOps, where I have defined the Azure pipelines.yaml. And you can see the changes I've made and each stage that I've used. So that completes the demo. Now, presenting a solution like this to the customer actually raises some eyebrows. Now, these are some questions that customer has asked back from you about this strategy. So the first question is, now, are there many ways to deploy Docker containers on Azure? What are the pros and cons of each? Now, there are actually about 3 methods that you can use in Azure. Things like web app for containers, and it provides a simple PaaS, and it doesn't provide full-featured container orchestration. Then you have Azure Container Instances, ACIs, which is a simple, isolated solution. It doesn't provide much of management tooling, which needs for the enabling of workload scale and on demand. So it's ideal for container bursting scenarios. And the final option is AKS, which provides the scale on demand and provides a fully managed experience. And the second question the customer provides is, okay, why is the AKS option is the best? What does it provide? As we discussed throughout the session, AKS can provide a managed Kubernetes cluster experience where the management layer is abstracted from the user, and it is the ideal solution to provide scale and management of workflow requirements if someone is deploying a containerized application into Azure. Well, I hope you learned a thing or two about embracing containerized application development with AKS and Azure DevOps. And thank you for attending this session, and I hope to see you next year.